You can see out there the definition of Fourier transform. X omega, omega is the frequency, f of x of t, here x of t is the function. So the definition of Fourier transform can be written as integration in it will be integrated from minus infinity to plus infinity x of t exponential minus omega t dt. So we are integrating with respect to t, and here x of t represent the function. Now one example, find Fourier transform of function cos omega naught t. So we know that cos omega naught t can be written as half exponential I omega naught t plus exponential minus I omega naught t, so which is known as Euler formula. So we have Fourier transform of exponential plus minus I omega naught t, where it is given by 2 pi rho omega minus plus omega naught. So if exponential plus I omega naught, then we get 2 pi rho omega minus omega naught, and if it is exponential minus I omega naught t, then we get plus. So this is the Fourier transform of exponential plus minus I omega naught t. Now we will find Fourier transform of our function cos omega naught t. So this can be written as out here half, then we will substitute the Fourier transform of exponential plus omega naught t, which is 2 pi rho omega naught omega minus omega naught, plus then we have exponential minus I naught, which is 2 pi rho omega plus omega naught. So simplifying, so we get pi rho omega minus omega naught plus pi rho omega plus omega naught. So this is the Fourier transform of cos omega naught t. So we can see out here the signal amplitude is pi. Now if we represent the signal, so this is the given signal cos omega naught t. So here x-axis represent time t, which I have shown out here, and y-axis represent the function x of t, which is cos omega naught t. So if we can, now I am considering omega naught frequency equal to 2 radian per second. Now after transforming this signal, that is cos omega naught t, by Fourier transform, so we have this signal which is spectrum, which can be represented as shown out here. So y-axis is x omega and x-axis represent frequency omega, which is in radian per second. So as you can see from the Fourier transform, so we have only two signal. The signal is at omega is equal to plus minus omega naught. So out here at minus 2 at the amplitude pi we have one signal, and also at plus 2 at amplitude pi we have one signal. So this is the representation of spectrum of cosine in the frequency domain. So this is Fourier transform of cosine omega naught t.